Hello everyone, let me check if my stream was started. Yeah, I'm trying to use Restream Service today to be available both on YouTube and Twitch. And yeah, looks like it's working, but what we can config here, we can update titles. So what we're learning today is Enums. Looks fine. So yeah, looks like we are good. So basically what we read last time, it was defining an enum, first section of chapter 6. Let's quickly take a look what we learned there. So enum is another data type, like we learned structure before, and what was interesting, we can associate some specific types with each field. Like here we have enum IP address, and with v4 version we associate like for u8 numbers, and with v6 we associated string. We also can have yeah, like tuples, everything, any type we can associate with it. We can do implementation, we can implement some methods, functions for this type. And we also start learning about option and the concept of null, which is not a part of Rust. Instead, there is the option enum, which represent is there any value or there is no value. Okay, but yeah, we stop at point how we can use this actually option, because I guess it require for example match expression, and this we should find out in this the match control flow construct section. So let's start with it. So Rust has extremely powerful control flow construct called match that allow you to compare values against a series of patterns and then execute code based on which pattern matches. Okay, yeah, patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 covers all the different kinds of patterns and what they do. So this is something we'll learn later. Chapter 18 is somewhere in the end of the book. We are just on chapter 6. Hope to finish it today, by the way. So yeah, let's continue. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirmed that all possible cases are handled. Okay. So yeah, this is maybe important part, that compiler confirms that all possible cases are handled. This is maybe something interesting. Think of match expression as being like a coin sorting machine. Coins slide down a track with various sized holes along it, and each coin falls through the first hole it encounters that it fits into. In the same way, values go through each pattern in the match, and at the first pattern the value fits, the value falls into the associated code block to be used during execution. Speaking of coins, let's use them as an example using match. We can write a function that takes an unknown US coin and, in similar way as counting machine, determines which coin it is and return its value in cents, as shown in listing 6.3. So penny, nickel, and here's the match. This is basically num and function. Yeah, let's, as usually we do, let's implement it. I don't know, we maybe can just clean up our code from experiments of previous section and start do it from scratch. So we have a num coin, and basically just define different types: nickel, dime, quarter. Yeah, I actually don't familiar with it. Let me quickly translate it into Ukrainian. No, it's don't provide any additional information for me, so let's left it as it is. And now we can use match with oh, sorry, yeah, we want to create a function. What the function do? Value in cents. So value in cents, coin, type coin, what we return something like U8, I guess, and basically return what the match returned to us. So coin, so coin is, I guess, a name. Yeah, I see now. Coin is the name of wine. Sorry, penny is the name of 1 cent coin, actually. So Copilot says nickel is 5. Dime 10 and quarter is 25 cents. And maybe, yeah, we can create some coin. Let's have quarter, biggest one. and try to print it. Cargo run. Okay, it's building, and yeah, you see output is 25, exactly what we expected. So yeah, let's try to understand what actually match is doing here. So it try to understand what kind of type of coin, and after the error it execute, I guess it's execute the code after the error. It could be some more complicated code. For example, I guess we can do something like this. We can print lucky penny or something, and then we can, by the way, will it provide an error? I guess it should, yeah, because it doesn't return a value. So if we return a value like this, it should be fine again. So let's change the coin to penny and run the code again, and you see there is lucky penny. So basically it match the enum type and execute code after the error. Somewhere we read that compiler makes sure that we cover all cases. So let's try remove one case and let's see what happened. Yeah, and you see Rust analyzer said to us missing match IRM, DIME not covered. So yeah, Rust take care for us that all coin cases covered in this situation. Because yeah, otherwise if we don't have some case and we get coin with this case, the behavior is unclear, it's undefined, and we can't return expected U8. So it makes sense, totally makes sense to me. I guess we can back to yeah, to the book, continue reading. So yeah, just quickly check the chat on Restream. No actions here, so we are good. Yeah, let's break down the match in the value and sense function. First we list the match keyword followed by an expression, which in this case is the value coin. This seems very similar to a conditional expression used with if, but there is a big difference. With if, the condition needs to evaluate to a boolean value, but here it can be any type. The coin, the type of coin in this example is the coin enum that we define on the first line. Yeah, this is interesting point. Like if expect the boolean, but match can take anything, but I guess somehow it do comparison, or yeah, it's interesting. Let's read what they're next. Next are the match arms. An arm has two parts, a pattern and some code. The first arm here has a pattern that is the value coin penny, and the error operator has separates the pattern and the code to run. The code in this case is just the value 1. Each arm is separated from the next with a comma. So yeah, this is how it called there. It's like the match value and case. So it's something similar to switch case, I guess, at this point to me. Maybe just a bit more straightforward. We have, yeah, like in switch, we put coin, and then if in this case we do this code block, if in this case, etc. Interesting, there is no comma as was said, each arm separated by comma. And here is no comma. If I, maybe it's just typo. No, it works without comma as well. So if we have explicitly block type, we don't need comma, I guess. If we remove it here, yeah, we have a problem. But if we do it in square, in curly brackets, I guess we will not have a problem. Okay. Important to know. So far it's something similar to switch case in different languages. So when the match expression executes, it compares the resultant value against the pattern of each arm in order. If a pattern match the value, the code associated with pattern is executed. If the pattern doesn't match the value, execution continues to the next arm, much as in coin sorting machine. We can have as many arms as we need. In listing 6.3, our match has 4 arms. So yeah, same as switch, we like going first, we compare to this one. If it's not penny, we're going to the second one, check if it's not nickel, I'm going to dime. If it's dime, we execute the code here and queue it from the mesh. We don't go to next one. Okay. The code associated with each arm is expression, and the resultant value of the expression in the match arm is value that gets returned from the entire match expression. So yeah, what we are going to return from each arm will be returned from the match itself. Okay. We don't typically use curly bracket in if the match arm code is short, as it is in listing 6.3, where each arm just return a value. If you want to run multiple lines of code in a match arm, you must use curly brackets, and the comma following the arm is then optional. Okay, yeah, we already found out all these pieces ourselves. For example, the following code prints lucky penny every time the method is called with coin penny, but still return the value of the blocks 1. Yeah, we already did this. So we can move forward. Pattern that bind to values. Another useful feature of match arm is that they can bind to the part of value that match the pattern. This is how we can extract value out of enum variance. Not really get it so far. As an example, let's change one of our enum variants to hold data inside it. Okay. So okay. So we want to attach the value to the quarter. From 1999 through 2008, the United States minted quarters with different design for each of the 50 states on one side. No other coins got state design, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state value stored inside it, which we've done in listing 6.4. So let's create another enum. Yeah, there is a macro derive debug, which will allow us to print it. Yeah, we will go just with 2 here. Alabama, Alaska. Yeah, I don't really familiar with US states. I guess Georgia would be something. Include actually Copilot can suggest something. I'm not sure if it's correct, but still let's have it. And now we can say that the quarter is US state type. And now our code is invalid. Interesting. Yeah, let's try to run it. Cargo run. Expected unit struct, unit variance or constant found, tuple variant, coin quarter. Use the tuple variant pattern syntax instead. So the syntax will be different, and Okay, like this, I guess. Oh, there is value will be. Let me. Can we just like this? And I guess what we can do now, we can take this state. Yeah, just print it. That's why we do derive debug. So we can print it and of course return again the value. And so what we can do here, quarter, and we should do use state Georgia, and let's have a look. Start the run. Yeah, state quarter from Georgia. You see the sprint. Okay, so basically we can extract the value from the enum if it has associated, and actually compiler kind of required us to do this. This is interesting. So let's continue. Let's imagine that a friend is trying to collect all 50 state quarters, in our case only 4, while we sort our loose change by coin type. We'll also call out the name of the state associated with each quarter, so that if it's one our friend doesn't have, they can add it to their collection. In the match expression for this code, we add a variable called state to the pattern and matches a pattern that matches values of the variant coin quarter. When a coin quarter matches, the state variable will bind to the value of the quarter state. Then we can use state in the code for that arm, like so. And yeah, exactly what we did. And actually here we can do another match, I guess, and for the state, not sure what we can return there, but anyway. Yeah, we have enum and we can use match for it. If we were to call value in sense like this with US state Alaska, coin would be coin quarter US state Alaska. When we compare the value in each of the match pattern, none of them match until we reach coin quarter state. So until we reach this point. At this point, we binding for state will be the value US state Alaska. We can then use the binding in the println expression, thus getting the inner state value out of the coin enum variant from quarter. And yeah, this is exactly what we did. So we can continue matching with option T. Yeah, this is the interesting part that we finished last time, this option type, option enum type, and this whole conception of either the variable have value or there is no value. So there is known and some. in this option enum. Okay. In the previous section, we wanted to get the inner t value out of the sum case when using option t. We can also handle option t using match, as we did with the coin enum. Instead of comparing coins, we'll compare the variant of option t, but the way the match expression works remain the same. Let's say we want to write a function that takes an option I32, and if there is a value inside, add 1 to that value. If there isn't a value inside, the function should return the none value and not attempt to perform any operations. This function is very easy to write thanks to match, and will look like this listing. Yeah, basically interesting. I'm so like sticky to this concept, like we have null and we check if it's not there, but in Rust it works differently actually, so I guess it somehow will change programmer behavior, how we do our code. So really interesting. Let's try this code snippet. So what we have function +1 which accept option and return option as well. Let's quickly write it down. And +1, yeah, x option I32, and we also return option I32. And what we do match x in case sum, let's call it value. We returns as copilot suggest sum, because we want to return option type as well. So we return +1, comma, and in case none, return none. This should work perfectly fine as I see so far. And yeah, so I'm just lazy to type it myself, but what we have here, we have 5 optional I32. Yeah, is it? Yeah, it's automatically casted to I32 from 5. Then we have +1 5, and we got 6, supposed to at least. And yeah, can we just print all the results like 6 and none, and maybe yeah, let's oh, I put it not in main, sorry. I wanted to put it in main, of course. Looks good. Cargo run. And yeah, we have sum 6 and none. Yeah, and as usually, I'm curious about this ownership concept, and what I want, of course, to try is if I can still use 5 or it was moved, and we are still good. Yeah, because we operate with IRC2, and I guess if we change it to string, for example, we will lose ownership. But yeah, don't want to stuck on it right now. Let's keep going through our enum chapter. So let's examine examine the first execution of +1 in more details. When we call +1 5, the variable x in the body of +1 will have the value sum5. We then compare that against each arm. The sum5 value doesn't match the pattern none. We actually write it down in different direction, I guess. Yeah, here it's none first. In our case, we do sum first. So we strictly jump to this like it's our first case. Yeah, for match, and yeah, and our arm execution block in work here. So the sum5 value doesn't match the pattern none, so we continue to the next arm. Does sum5 match sum I? It does. Well, of course it does. We have the same variant. The I bind to the value contained in sum. So I take the value 5. The code in the match arm is then executed. So we add 1 to the value of I and create new sum value with our total 6 inside. Now let's consider the second call of +1 in listing 6, 5, where x is none. We enter the match and compare to the first arm, none, none. Yeah, in our case, with this none +1 none, we compare with sum, it's not sum, it's none, so we execute this and just return none in this case. So it matches no value to add to, so the program stopped and returned the non-value on the right side of arrow. Because the first arm matched, no other arms are compared. The combining match and enums is useful in many situations. You'll see this pattern a lot in Rust code. Yeah, I guess so. Match against an enum, bind a variable to the data inside. Match against an enum, bind a variable to the data inside, and then execute the code based on it. It's a bit tricky at first, but once you get used to it, you wish you had it in all languages. It's consistently a user favorite. And this is I guess it's cons of Rust, like the part when you learn and start using Rust, you might be still working on different job with you're using daily different language, and you see those cool features of Rust and you wish you have it daily, but no, you suffer from your current language. Yeah, this is our life. But anyway, let's continue. Matches are exhaustive. So there is one other aspect of match we need to discuss. The ARM pattern must cover all possibilities. Consider the version of our +1 function which has a bug and won't compile. So yeah, here we do not provide none. We already tested it ourselves, but yeah, let's do it again. Just comment out none. Sorry, let me turn off sound on my phone. Yeah, we commented none, and compiler will not allow us. Sorry, I didn't save. Let's run, and we get an error. Non-exhaustive pattern, none not covered. So straightforward, what we just read in the section title. So yeah, I don't know what to say. It's really straightforward. We already find out it. We didn't handle, so yeah, just let's continue reading. We didn't handle the non-case, so this code will cause a bug. Luckily, it's bug Rust know how to catch. If we try to compile this code, we'll get this error. Exactly. We tried it, non-enhanced pattern, none not covered. So basically we should cover a non-case. Rust note we didn't cover every possible case and even know which pattern we forgot. Matches in Rust are exhaustive. We must exhaust every last possibility in order for the code to be valid. Yeah, it's actually this how to say this feature of the, let's say it's feature of the match is like different from switch cases I mentioned before, like in different languages we usually use and new. So in switch case it's your responsibility to where we want to cover all cases or not, or you can have default. This is actually interesting. Yeah, default, there is no sense for default in case you're not covering something, because you have to cover everything. In the switch case it's solved by default, but also default is not required, I guess, in most languages. So yeah, we must exhaust every last possibility in order for the code to be valid. Especially in the case of option T, when Rust prevents us from forgetting to explicitly handle the non-case. It protects us from assuming that we have a value when we might have null, thus making the $1 billion mistake discussed earlier possible. Yeah, there was in previous section we have this $1 billion mistake. Yeah, it's presentation, the $1 billion mistake, null reference. Tony Hoare, who was an inventor of null. This is just fun fact. But yeah, let's continue. Catch all pattern and the underscore placeholder. Using enum, we can also take special action for a few particular values, but for all other values take one default action. Yeah, let me read it again. Using enums, we can also take special actions for a few particular values, but for all other values, take one default. Okay. So dice roll match. Okay, there is alternative to default. You see, there is other, I guess. Let's read. Imagine we are implementing a game where if you roll 3 on a dice roll, your player doesn't move, but instead get a new fancy hat. If you roll 7, your player loses a fancy hat. For all other values, your player moves the number of spaces on the game board. Here is match that implement that logic. With the result of the dice roll a hard-coded rather than random value, and all other logic represented by functions without bodies because actually implementing them is out of scope for this example. So yeah, let's quickly copy this into our main function. Also this let's do formatting with cargo fmt. So basically, if we remove other, it requires us to cover all possible cases, and if we just work with numbers, it's a huge amount of cases, and we don't want to deal with them. In this case, we have just other, and for everything else, we will have this one. Yeah, same as switch default. Maybe main difference is required if we don't cover. One thing I want to try is if we can do others none. So if we can do really, will it work? Okay. Yeah, I think this underscore will cover it. Just right there because it was in the title. Underscore placeholder. So let's take a read. For the first two arms, the pattern, yeah, let's see the code. First two arms, the pattern and the literal values 3 and 7. For the last arm that covers every other possible value, the pattern is the variable we're choosing to name other. So other doesn't really should be other. In this case, we can say some other. I guess we can even do like this, I guess, and still run and it's working. Okay, this is something we should know. The code that runs for the other arm uses the variable by passing it to the move player function. This code compiles Even though we haven't listed all the possible values U8 can have. Because the last pattern will match all values not specifically listed, this catch-all pattern meets the requirement that match must be exhaustive. Note that we have to put the catch-all arm last because the patterns are evaluated in order. Yeah, makes sense. So it starts with yeah, if we put it on the first place, it will be always work as first and we never reach other arms. Yeah, if we put the catch-all arm earlier, then other arm would never run, so Rust will warn us if we add arm after a catch-all. Yeah, it's so nice, like we can catch the logic for a hit before we read it. We're trying to understand why this thing's done this way, and then read the explanation and match our understanding with what is the reality is. It's, yeah, I think it's kind of good thinking process which train us, which improve our understanding how things work. This is just good. So Rust also has a pattern we can use when we want a catch-all but don't want to use the value in the catch-all pattern. Underscore is a special pattern that matches any value and does not bind to that value. This tells Rust we aren't going to use the value, so Rust won't warn us about an unused variable. Let's change the rules of the game now. If you roll anything other than 3 or 7, you must roll again. We no longer need to use the catch-all values, so we can change our code to use underscore instead of the variable named other. Yeah, we actually, this is what we tried. Like we can quickly add function reroll, and instead of this we can reroll and do cargo run to check if we did any mistakes, but looks like we are fine. So this example also meets the exhaustiveness requirement because we are explicitly ignoring all other values in the last arm. We haven't forgotten anything. So yeah, this is, I think, interesting point because thing is here is explicitness. We don't forgot something, yeah, we ignore it and we explicitly show in the code for everything else we do this and everything else we do this. If we just like didn't force to do it explicitly, in this case we even another programming came and don't understand what's going on, because did you miss something or you did it explicitly, it's not clear. And another case, you just forgot something, and yeah, but when everything is explicit, everything is clear. So finally, we've changed the rule of the game one more time so that nothing else happens on your turn. If you roll anything other, oh my gosh, I have a raid. Hello everyone, Yeah, I'm just trying to learn Rust. Like I'm software developer like for more than 10 years, and just as a fun, learning Rust by reading the book and try to discuss it on stream, how I understand what I'm reading. So feel free to follow if you're interested in such content. If you already knew Rust, you can tell me something. I'm not understand, so help me and my watchers to learn better. So yeah, welcome again. We now on chapter 6, enums and pattern matching. Actually finished section 6.2, and I think we will cover today 6.3 as well. This is where we are. Things going more and more exciting with each chapter. Basically, yeah, so welcome everyone again, and yeah, let's continue. And yeah, Toggle bit, thanks for the raid. I was on your stream today, and yeah, I just understand. I'm not as far to understand what everything you're talking about, so push myself to continue reading the book. So back to our enums. Finally, we've changed the rule of the game one more time, so that nothing else happens on your turn if you roll anything other than 3 or 7. We can express that by using the unit value, the empty tuple type we mentioned in the tuple type section. So the code that goes with the underscore arm. So yeah, again, we explicitly say we don't want to do anything in all other cases. We just return, or we don't return. Empty tuple. We can let's check again. Finally, roll anything. We can express that using unit value. The empty. But what happened? Will it return empty tuple? I guess it should, in all these cases, return unit value, right? If we this is basically says like end of the code block without semicolon, we return it. And here we return the value of the function, and this return value also unit type, and here as well. I think we can quickly test it. Like so yeah, Rust analyzer tell us the match value is unit type. Exactly. So here we are telling Rust explicitly that we aren't going to use any other value that doesn't match a pattern in the earlier arm, and we don't want to run any code in this case. Okay. there is more about patterns and matching that we'll cover in chapter 18. For now, we are going to move on to the if-let syntax, which can be useful in situations where the match expression is a bit wordy. Yeah, actually, I have this feeling that like it's not something we would like to use everywhere. Maybe we will use it a lot, but not everywhere. So let's see what the concise control flow with if-let. I think I saw something like this in the Swift. I'm not doing like a lot of Swift, but yeah, I'm React Native developer mostly those days, and when I need something to do on the native side for iOS, sometimes I have to deal with Swift, and it looks very common, at least at this point. Let's read about it, what it actually do. So the if-let syntax let you combine if and let into a less verbose way to handle the values that match one pattern while ignoring the rest. So less verbose way to handle values that match one pattern. Well, okay, consider the program in listing 6.6 that match on an option U8 value in the config max variable, but only wants to execute code if the value is the sum variant. So yeah, this is the case where we might be don't really want to use much because we won't ignore all the arms except one. So there will be another beta mechanism to do this. Now, if the value is sum, we print out the value in the sum variant by binding the value to the variable max in the pattern. We don't want to do anything with the non-value. To satisfy the match expression, we have to add underscore and return any unit type. After processing just one variant, which is annoying boilerplate code to add, instead we could write this in shorter way using if-let. The following code behaves the same as the match in listing 6.6. So yeah, let sum max equal config max. And this is okay. So let we create new variable sum max, but max also is coming from config max. So it's kind of destruction of the config max and see if it's sum, not none, and if it's sum, we get in value from it. Let's just quickly edit our code and try to run it to make sure everything is working. yeah, we have this println output. Maximum is configured to be 3. Okay. The syntax if let takes a pattern and an expression separated by an equal sign. It works the same way as match, where the expression is given to the match and the pattern is the first arm. In this case, the pattern is sum max and the max bind to the value inside the sum. We can then use max in the body of the if let block in the same way we used max in the corresponding match arm. The code in the if let block isn't run if the value doesn't match the pattern. Okay, so yeah, basically if we want to, for example, execute something in some case, and we're not going to, we basically don't need to cover all cases. We just, in some particular case, we just pick it and use it. Yeah, much from the syntactic level, it's much better than to have use the match instead. So I think it's just fine. So in other words, we can think if let as syntax sugar for a match that runs code when the value matches one pattern and then ignore all other values. We can include an else with an if let. The block of code that goes with else is the same as the block of code that would go with underscore case in the match expression. That is equivalent to the if, let, and else. Recall the coin enum definition in listing 6.4, where the quarter variant also held a US state value. If we want to count all non-quarter coins we see, while also announcing the state of the quarters, we could do that with match expression like this. So we match the coin, and in case it's quarter with the state value, we print it. In all other cases, we just increase our counter. So we count how many non-states, non-quarter coins we have. Or we can use an if, let, and else expression like this. Let, yeah, if let coin, yeah, basically the same, but I don't know, maybe we need to practice with it more. I'm not sure, maybe it's more clear in this case, like if we do this, else we do this, but match is also kind of clear. So if you have a situation in which your program has logic that is too verbose to express using a match, remember that if let is in your Rust toolbox as well. So yeah, there is no like direct recommendation. It's more about how you feel. If you want to use let with else, or you like match everywhere, you can do this, but generally it's as usually in programming world, you rely on your feeling, how, at least for me, it's like how pretty your code, like how readable when you interact with code from other people's, you like see, and is it very clear, or is it like what's going on here? It's so unclear. Maybe you should do something else. So, but yeah, it still can be different styles in which not much your style, and this could confuse you as well. So the summary of the chapter 6 of Enums. We have now covered how to use enum to create custom types that can be one of a set of enumerated values. We've shown how the standard library option T type helps you use the type system to prevent errors. When enum values have data inside them, you can use match or if let to extract and use those values, depending on how many cases you need to handle. Your Rust program can now express concept in your domain using structs and enums, creating custom types to use in your API ensure type safety. The compiler will make certain your functions only get values of the type each function expects. Okay, in order to provide a organized API to your users that is straightforward to use and only exposes exactly what your user will need, let's now turn to Rust modules. Okay, so the next chapter is the modules. Yeah, the most interesting thing for me at least was this option and this concept of null. There is actually was some particular guy that create this concept of null, and it's kind of natural, at least because is we have usually two states, the value exists or it's not exist. So it's kind of null or not null in common way, but Rust is changing this concept somehow and use this option type where we have value or we don't have value, but it's not null. It's kind of different, and I'm not really sure how it affects me when I will write the Rust code, but I'm already feeling it will. Like, and this is actually why it's interesting to learn like different languages with new concepts and see what else it can offer to you. So let's quickly check managing growing project with packages, crates and modules. So yeah, before this point, like we always stick in one file main.rs, but yeah, of course we would like to split our code to different places. So this is always the question when I try to quickly write on some new language for me. For example, like sometimes I do something in Python, but I don't really sit and learn it properly, so I just try things there, and it's like in this case it's always the question, oh, how I should import something from different file, how should I organize my code, etc. So this is the common question you should cover when you properly learn some new language. I think this is it for today. Yeah, I need to go do some stuff outside. But if you like interested in this format of learning Rust, so follow me. I don't have like schedule so far. I'm just learning to stream and everything like this. So yeah, I'm thinking about not just reading Rust book. Yeah, for Rust, definitely I want to read it and start to do some programming in it on stream. But also, as you can see, I'm using NeoVim, which I'm kind of new. Like I've started like half a year ago, and this NeoVim world is also interesting. Like to write some plugins in Lua, etc., and do some configurations. So I might will do this kind of streams as well. Also do mobile development in React Native. So basically any topics I'm interested in, maybe write some scripts in Python or whatever I curious about at the moment. I'm actually like to do streams. Anyway, thanks everyone for watching. Hope to see you next time.